Hello, my name is Janne Wallenius. I am professor in reactor physics here at KTH. I'm also responsible for the course in Generation 4 reactors, and this is a course that's going to change the world. Let's go back to electricity. Electricity is the key to a good life for all of us on this planet. Today, about 12% of this electricity is produced by nuclear power. Now, some people think that we should get away from using nuclear power because it's perceived as being unsafe. Well, how unsafe is it really? If we compare different ways of producing power, we actually see that oil and coal are the worst offenders. Comparing the renewables with nuclear, we find that nuclear is safer than all of them. In the same time, we know that global electricity consumption will have doubled in 2050. At this time, we should also have reduced our greenhouse gas emissions to 20% of the current level. So, of course, nuclear power should be a part of this energy mix, since nuclear is the safest way of producing energy. The question may arise, how much nuclear do we need? Well, to meet the climate objectives, the International Energy Agency forecasts that in 2050 we should use 25% nuclear power and 80% wind power. In order to meet these objectives, the wind power industry has to build nuclear power plants at a pace which is 5 times higher than today, whereas the nuclear industry will have to build about 1,000 large power reactors. This will mean that the uranium price will rise, we will get more nuclear waste, and of course there is a concern about safety. We certainly need to avoid the type of accidents that occurred in Fukushima, which means that the new reactors that we develop must not force people to evacuate in case of an accident. But we may use this opportunity also to develop reactors that can recycle waste and increase fuel resources by 100 times, leading to less than 1% of the current high-level waste stream. Such reactors are called Generation 4 nuclear systems, and this is what this course is about. So in this course, we shall actually learn how to design sodium and lead-cooled reactors that are capable of recycling nuclear waste. We will learn by home assignments and a project work to assess their safety performance. And you will also be able to select the best possible fuel compositions for these reactors. Here in this image you see a picture of Astrid, which is a Generation 4 reactor that is planned to be built in France. So Generation 4 reactors are actually real. This course will teach you everything you need to know about Generation 4 reactors. In particular, we will study how to design sodium and lead-cooled reactors that are capable of recycling nuclear waste. We will do home assignments where we assess their safety performance, and you will understand how to select the best possible fuel compositions. We will do these exercises using models of Generation 4 reactors that are under planning today, such as the Astrid reactor in France, which you see on the picture here on this image. Now, does the performance of Generation 4 reactors sound too good to be true? Is it ever going to be a reality? We know that fusion is always 50 years in the future. Will it be the same for Generation 4 reactors? Well, currently research made at KTH has resulted in a microreactor design with Generation 4 capabilities called Sealer. The idea is to deploy this microreactor for commercial power production in the Canadian Arctic within less than 10 years from now. If you take the opportunity to participate in the Generation 4 reactor course, you will be able to carry out your master thesis on the design and safety analysis of this reactor. This is an offer that certainly is irresistible.